Space rockets are fascinating marvels of engineering that have captured human imagination for decades. Let's dive into how they work, step by step, and explore the intricate details that make space travel possible. The basics of rocketry. At its core, a rocket is a vehicle designed to propel itself by ejecting exhaust gas from one end. This principle is based on Newton's third law of motion. For every action, there is an equal and opposite reaction. When a rocket expels gas out of its engines, it generates thrust that pushes the rocket in the opposite direction. Components of a rocket. Propellant. This is the fuel and oxidizer that the rocket burns to produce thrust. Rockets carry their own oxidizers because there's no oxygen in space. Engines. These are the heart of the rocket, where the propellant is burned to create high-speed exhaust gases. Structure. This includes the frame and skin of the rocket, designed to withstand the stresses of launch and space travel. Payload. This is the cargo the rocket is carrying, which could be satellites, scientific instruments, or even astronauts. Guidance system. This system ensures the rocket follows its intended path, using computers and sensors to make real-time adjustments. Stages of a rocket. Most rockets are multi-stage, meaning they have multiple sections that are jettisoned as the rocket ascends. This design is efficient because it sheds weight as the rocket climbs, making it easier to reach space. First stage. This is the largest and most powerful stage, responsible for getting the rocket off the ground and through the densest part of the atmosphere. Second stage. Once the first stage is jettisoned, the second stage takes over, continuing to propel the rocket into space. Third stage. Some rockets have a third stage for additional thrust, especially for missions that require reaching higher orbits or escaping Earth's gravity entirely. The launch sequence. Pre-launch. Before launch, the rocket undergoes extensive checks and fueling. The launch pad is cleared, and the countdown begins. Ignition. The engines ignite, and the rocket begins to lift off. This is a critical moment, as the engines must produce enough thrust to overcome Earth's gravity. Ascent. The rocket ascends through the atmosphere, with the first stage burning until its fuel is exhausted. At this point, the first stage is jettisoned. Stage separation. The second stage ignites, and the rocket continues its journey. This process may repeat if there are additional stages. Orbit insertion. Once the rocket reaches the desired altitude and velocity, the final stage shuts down, and the payload is deployed into orbit. Types of rockets. Liquid-fueled rockets. These rockets use liquid propellants, which can be controlled more precisely. They are often used for manned missions and deep space exploration. Solid-fueled rockets. These rockets use solid propellants, which are simpler and more reliable, but less controllable. They are often used for military applications and some space missions. Hybrid rockets. These rockets use a combination of solid and liquid propellants, aiming to combine the advantages of both types. Challenges in rocketry. Weight. Rockets must be lightweight yet strong enough to withstand the forces of launch and space travel. Fuel efficiency. Carrying enough fuel to reach space while keeping the rocket's weight manageable is a significant challenge. Heat. The engines and the rocket's exterior must withstand extreme temperatures during launch and re-entry. Guidance and control. Ensuring the rocket follows its intended path requires sophisticated guidance systems and real-time adjustments. Innovations in rocketry. Reusable rockets. Companies like SpaceX are developing rockets that can be reused, significantly reducing the cost of space travel. Advanced propellants. Research is ongoing into more efficient and environmentally friendly propellants. Miniaturization. Smaller, more efficient rockets are being developed for launching small satellites and other payloads. The future of rocketry. The future of rocketry is incredibly exciting, with plans for missions to Mars, asteroid mining, and even space tourism. Advances in technology and engineering continue to push the boundaries of what is possible, bringing us closer to a future where space travel is more accessible and routine. Conclusion. From the basic principles, thrust and propulsion, to the sophisticated guidance systems and innovative designs, rockets are complex machines that open the door to the final frontier. As technology advances, we can look forward to even more incredible achievements in space exploration.